so today I'll be seeing whether the Memper effect will work. Memper effect means that when you put this boiling water 100 degrees C in the freezer, it will freeze faster than cold or normal room temperature water. Is it true? So today this is a boiling kettle and this is at 100 degrees C or 212 Fahrenheit and it's extremely dangerous. So it's actually boiling now at 100 degrees C, and so now we are going to put it in a metal container where we will be freezing it in the fridge for 15 minutes. I'll be counting down with my phone. Alright, so and then after 15 minutes I'll check with you all the results. So this is the boiling water at 100 degrees C. Let me turn off the tap first and close it all up. So you can see, check it out. You can see it's a lot of steam and that's quite hot. So we will not be using other material because for ceramic it can cause cracking in the glass because of the uneven thermal expansion and contraction. So we'll be using this one right here, which is a metal baking tray, and the water set to 100 degrees C, and I'll be wearing gloves to protect myself to prevent scalding when using the hot water. So I'm gonna pour the hot water onto this metal tray right here, and I'm gonna put it in the freezer for the thing to freeze and see what happens. So this is the tray that I'll be filling up with hot water. Be careful not to scald your hands as always. Just gonna put half, maybe half is enough. Don't need too much. And this is the newly boiled water. So I'm just gonna shift it to the refrigerator and just set it to freeze because now it's not cold enough. So let me just set it there. Okay, and then just go back to there. Let's try again. So close the fridge and start the timer. So we have 15 minutes to go, and we will see what's the result just after 15 minutes of inside the fridge. The Memper effect. Hot water freezes faster than cold water. We have 14 minutes to go and we'll see you there soon.
A few moments later.
Okay, so it's about time, so let's go and check out our ice. Okay, it's still liquid. Can see it's still liquid though. So and then there's a lot of things. So we'll be setting it for another 15 minutes because I think 15 minutes is not enough time to actually cool down the hot boiling water. So let's go for another 15 minutes.
Later.
Okay, so another 15 minutes up. Let's go and check out. It's still liquid. It still can feel it is liquid. So 15 minutes is not enough. So let's go for another, say 5-10 minutes and see whether it will freeze. So after 30 minutes of inside the fridge, or rather freezer, it didn't freeze at all. It's just very cold. It's probably at like 5 degrees C or so. So let's go again. 10 minutes.
Later.
Okay, so now another 10 minutes is up, so total time is 40 minutes. So let's turn on the flashlight and go and check on the ice thing. There is a bit of the things that you can see there is a bit. It's still liquid. So let's go for another
5 minutes now.
So total time is 45 minutes. And we'll see you there.
Later.
Okay, so another 5 minutes is up, so total is 45 minutes, okay? So let's go and check out the ice. Is it ice? Still, oh, it's frozen already. Let me see. Wow. It's like, you know, the lake at the bottom, so it freezes, the top has frozen already. So we'll count it as 45 minutes. Actually 46 minutes for a few seconds of the like taking out and putting back. So 46 minutes to freeze from this to see, I can feel it, there's a bit of the ice there. But it's like, you know, the lake, saw that? There's a bit of ice there, so it's quite good. So it actually is 46 minutes, so 46 minutes, 45 plus 1, 46 minutes. So you can see that it's frozen already at 46 minutes. I'm gonna empty this thing up. And we're gonna try again with normal tap water at 30 degrees C. And then we're just gonna warm this thing up a bit. So this is the same amount of water, but at 30 degrees C, and let's compare the difference. Let's set the timer to 20 minutes for normal temperature water. Okay, so let's put it in again. Okay. Saw it. Okay, so we're gonna put it inside. And I'm gonna set the timer first to 20 minutes. 20 minutes. Right, so we'll be leaving this thing here and I'll be showing you after 20 minutes and let's see what happens.
20 minutes later.
Okay, so for 20 minutes for the one without boiling water one, so let's see what's the results. Yeah, still liquid. With a bit of the ice traces there, you saw that? Still liquid. When I touch it, you can see it's still liquid. So we are gonna go for another 20 minutes now. So yeah, 20 minutes. And we'll see you in 20 minutes.
20 minutes later.
So the time is up and now it's 5:33 PM and let's go check our ice. Looks alright, so let's open it up. Oh, it's frozen already. It's actually frozen. So it takes only 40 minutes actually to froze this thing. So look at that. Let me touch it. Okay, let me position the flashlight. It's really frozen. Look at that. It's faster than 100 degrees C boiling water. So, to be exact, it does not uphold. It could be true though, but it's around the same timing, I would say. It took around 40 minutes or lesser than that to actually freeze this tap water. But it takes also around the same time or not even a bit more to freeze boiling water. So you can see that, well, it's not actually true that boiling water freezes faster than normal temperature water. This is normal temperature water and it froze in 40 minutes. But the Memper effect, the water freezes in around 40 to 46 minutes. So you can see that it's not really true that boiling water freezes faster than cold water because it froze around the same time for me at least. So thanks for watching and I'll see you in the next video.